Here we go. So, exercise 9A, combining geometric growth and decay. All you had to learn from this section is you're combining geometric and arithmetic, meaning multiplication and addition or subtraction, right? So you can see here as an example, they said generating a sequence from a recurrence relation of the form, and they give you this. This is what 9A is about. So you got multiplication, you got addition. How's it different for what you've done? Not so much. You're still using your CAS, and I'll show you. This is V0. V0 is 3. So you're starting off with 3. That's V0. So according to this recurrence formula, V1 would then equal to V of 0 plus 1, which means I'm going to do 4 times V0 minus 1. And you type that on your calculator. So how do I do it on my CAS? This is what it'll look like. I'm just going to show you on the side. This must have been one of the examples beforehand. All right. If I were to do it, start off with 3. So recurrence model, we just press enter. That's what recurring means, recurrence. So I started with 3. What am I doing? I'm timesing by 4 minus 1. That's what the recurrence formula is telling me. It says times 4 and then minus 1. So that's what I'm doing. I'm going to say, all right, press enter. By doing that, 3 times 4 is 12. 12 minus 1 is 11. Then if I follow that same formula for the next one, so V1 is 11, V2, same thing, I'm going to press enter again. Whoops, over here. Press enter again, I get 43. So 11 times 4 minus 1 gives you 43. And you can see this recurrence model. Now, if I needed to find V10, the problem with recurrence models, you have to press enter every time. So that's 3, V4, V5, V6. Listening, shh, boys. Thank you. V7, V8, V9, V10. So the problem with recurrence is that though it's easy to understand, you have to repeat it over and over. Okay? So that's what exercise 9A is about. So if you think about, do I need to spend a lot of time in 9A? No. What do you need to know? How to model this recurrence formula. That's all you're learning to do in 9A. Okay, so it's kind of like your simple interest. There was a recurrence model, and in compound interest, there was a recurrence model. But then applying a formula is what you do later. Okay, so right now 9A is just an introduction of combining geometric with the arithmetic sequence. Okay? I would say it's just the beginning. So those who struggled in chapter 8, who didn't know how to write a recurrence model, which there was very few of you, most of you understood how to do it in chapter 8, then that's where you do it again in 9A. Okay? But that's what 9A is. So 9A shouldn't be hard. So you can see here, all I did was you've got 10,000, you start off with 10,000, and the model is times by 1.1 and minus 3,000, and that's what I did in my sort of solutions here for you to see. I just started with 10,000 times 1.1 minus 3,000, and that's how I answered my questions. They asked for V2, they asked for 2 months, I just entered it twice, and I've got V2 over there. Okay, so that's what 9A is practicing. After how many months will there be no trout left in the pond? Well, you keep pressing enter until you get down to 0. In my case here, it was a negative answer, so I know it's after 5 months. Okay, so after 5 months, that's when it gets down to 0. Okay, so that's what 9A is. Very simple, it's just working with the recurrence formula. How do you read the starting point? How do you read the pattern? How do you do it on your CAS? And it's just a recurrence, addition, subtraction, multiplication. Okay? All right, so 9A down. 9B. 9B is where I think it gets trickier in terms of understanding the table that you need, and that's where I want you to spend time this session. I want to get you to practice those questions, okay? So the first part shouldn't be challenging. First part is what you've been doing with the recurrence model. So what they talk about in 9B, is called reducing balance loan. A way that I like to think of it is this is what you'll be doing when you buy a house. When you buy a house, you need to get a loan, plus you got to pay interest. So just because you borrowed, say, $1 million, it doesn't mean by the end of 30 years that you're paying back only $1 million. It's 1 mil plus whatever the interest is, right? But along the way, you're chipping it away. Okay, so this is what we call a reducing balance loan. You want to see it reduce over time. How do you calculate that? After 1 year, how much have you paid off? After 2 years, how much have you paid off? how much more do you have? That's what exercise 9B is about. Okay, so here we go. When you're talking about a reducing balance loan, that's what 9A was trying to teach you. This is a recurrence model. This is how much you borrowed. This is the interest. R times VN will work out the interest added to the total, plus total, right? What's the minus D? That's you paying them back. Okay, now this is where some students may find this confusing. Plus, positive in general, this will help you when you get down to annuities and when you get to, annuities really. So when you get to annuities, we consider plus is when the bank gives you money. So write that somewhere. So when you borrow, so loaning. So when you get a loan, now often reality-wise is when the bank gives you money, technically it's not a positive money, it's negative because you owe them. But in this case, when you're working with this sort of concept, you need to get your head around the fact that money that the bank gives you, that's positive money, you gained money. Whilst you paying the bank back, which is a good thing, you're owing less, but you're losing money. So minus is when you're paying the bank back. So this is why in the formula, you can see here that R times VN is a geometric sequence. If you have 2% that you need to pay every month, 2% of the remaining balance, that's the amount that you're paying back. Okay, you're reducing the balance. If I don't have that amount, then you just keep owing them. Every year you owe them a larger amount. How much are you giving back? That reduces the balance. That's why this is called a reducing balance loan. Okay, so that amount is that how much you're paying. R is the rate. Okay, so I'm going to show you again, just to help you remember geometric sequence compound interest. Remember with compound interest, R talks about 1 plus the rate to the power of n. That's the formula, but in our case, we're not doing a formula, we're doing a recurrence. So it's that multiplied to what you borrowed, or what's left over, and then minus, this is D for how much you're paying back. Okay, just to give you that context. So let's do an example. Let's do an example so you can sort of understand what I'm trying to say there. This is an example. Alyssa borrows $1,000. Okay, so we've got $1,000. I'm just going to move this down a bit. Here you go. Alyssa borrows $1,000. So this is, you go to the bank, you borrow $1,000. This is how much you borrow. V0. The interest rate says it's 15% per annum. So 15% per annum is the rate that you pay back. So whatever the amount is, whatever's still left over every year, they will calculate 15% of that. Okay? But notice that they said compounding monthly. Okay? So it's not that every year they charge the interest. Every month they compound this. So they charge the interest every month. But that means the rate changes. So the rate is not 15% per annum. The rate now is 15 divided by 12, because there are 12 months in a year, percent. So that's the rate per month.
So it seems less.
Seems less.
No, it's not.
Correct, because the overall is that the interest is going to be much larger than, say, 15% of $1,000.
Yeah.
This is now going to be 15 divided by 12% of 1,000 12 times, and you'll find that that will add much more interest than just doing it once. Yeah. So on the calculator, I'm just going to quickly calculate what 15 divided by 12 is. So here we go. 15 divided by 12, I get 1.25. So this tells me it's 1.25% as my rate per month. Okay? Now, they said she will repay the loan by making 4 monthly payments of $257.85. So every month she's paying back $257.85. That's a monthly repayment. Okay? So when they say construct a recurrence relation to model this loan, this is just starting off so that you understand. In the first month when she first borrowed, she doesn't owe anything but just $1,000. After a month, VN plus 1, so you calculate for each month, the recurrence is you are not just doing 1.25%. Remember, it is R is 1 plus R over 100. That's the percentage. So it is 1 plus 1.25% means out of 100 multiplied to VN minus what you're paying back. So you're paying back $257.85. Okay, now just to put things in perspective, just in case you're looking at that and going, I don't understand what's happening, I'll show you. This is what's happening. You borrowed $1,000, right? The rate of interest has to then be 15%. Oh, sorry, 1.25%. That's 1.25%, okay? I'm doing 1.25% of $1,000. Listening? Shh. If I'm doing 1.25% of 1,000, you can see I'm multiplying by 1,000 now. This is how much interest I need to pay in the first month, $12.50, right? So if you think about it, I need to pay $1,000 after 1 month with an extra $12.50, okay? Now, I'm paying them back monthly minus $257.85. That's how much I'm minusing. So I'm starting off with $1,000 normally. This is how much I pay back. Oh, what's going on there? 1,000 minus 257.85. This is how much I would owe. But remember, it's not just $742.15. It's also including $12.50 because that's the interest that I need to pay back. Okay, so let's have to think about it again. This is your $1,000. I'm paying $257.85. So you borrowed $1,000. You paid me back this much. Technically, that's how much you owe. But we know that's not how the real world works. You don't pay at the end. You don't pay all 1,000. You pay 1,000 plus interest. What was the interest? It was 1.25% of what you owe at the time. So it's an extra $12.5 that adds on to this amount. That's how much more you're paying after 1 month. So that can all be calculated by this recurrence formula, R times Vn minus D. So that's what you're doing right now. So I'm going to show you 1,000, that's what you start off with, times 1.0125. Okay, so this is your rate, R, minus $257.85. So what I'm doing there is exactly this model right here. So when you add it together, that's 1.0125 multiplied to what you owe, and then this is what you repay. So this here will calculate the interest plus total. So it's your $1,000 plus interest. This is what you're paying back. Does that make sense? Okay, so you're paying back consistently of $257.85. But remember, your initial amount was $1,000, but they keep adding 1.25% every time. So 1 is the amount that you owe. That 0.0125 is the 1.25%. That's what they're doing every time you still have something left over. They're taking 1.25% of whatever's left over. So it's your $1,000 plus interest. Okay, so what you currently owe plus interest, and this is you trying to shave it down. So if I keep pressing enter on the calculator, this is what you'll see. So on the calculator, I started off with $1,000 right there, and I'm going to now press enter. This is how much I owe with interest. Okay, so not only did I pay $257.85. Remember, it was meant to be $742, but it's not $742 now. It's $754. Why is this larger? It's because they added interest to it. That's the interest amount that I'm missing. $742, technically, if there was never ever interest related, you would have just paid them back slowly. $257, that's what you owe, but I have an extra interest, that's why it's larger. So if I press enter again, this is what happens if you consistently pay $257 every month. So if I did it for 4 months, I would reduce from $1,000 to $754, down to $506. In the 3rd month, I'm down to $254. And then in the 5th month, okay, so that's now the 5th month, then I've reduced it down to 4 cents if I paid that consistently. Now, what you'll notice is later when I talk about amortization tables, in your banks, they often round that last value. They don't want you to pay 4 cents. It's like, you might as well, you're done. So in the last payment, your very last payment, instead of $254.71, you're missing that 4, or technically rounding it up, it's 5 cents. They'll add 5 cents to that last one. Okay, instead of paying $257.85, that you're missing that little bit. So they take that very last payment and they add on another 5 cents to that. And so your last payment should be $257.90. And that's how you close a balance. Okay, so that's why it's called a reducing balance loan. Now, amortization table is exactly the same, except it's much clearer what you borrowed. So you borrow a certain amount, there'll be a table that talks about how much principal you paid down and how much interest it has accrued. That's what you need to understand. So reducing balance loans and amortization tables are exactly the same, but understanding what those columns mean is what's tricky. Okay, so overall, what I wanted you to understand from here was this is the amount 1 plus the rate. Okay, in our case it's per month, so that's the rate times what's left over. So the recurrence is you keep pressing enter and it tells you how long it takes before you get down to 0. Okay? So, yes, exactly. So in this question here, I went a bit deeper, more than what you needed to understand, but hopefully you got a better picture there. This question only wanted you to do this. This is all they wanted you to write. So this is what they wanted you to write as your final answer. I'm giving you an understanding of what that recurrence means. So you're starting off with $1,000, you're timesing by 1.0125 means it's 1.25% every month, and you're paying back $257.85. Okay? Now, let's take that understanding and show you what an amortization table looks like. So, right here is an example of similar to that idea. So you've got the idea of borrowing. This is how much I'm borrowing. I'm borrowing $1,000 again. I'm paying $257.85, right? We just did that calculation before. Now you see what I showed you before, now let's put it all on the table. $1,000 is what you owed, so hence it's 0, 0, 0, 0, 0 interest paid, because you didn't owe anything yet. Principal reduction, you haven't reduced anything, you still owe $1,000. Payment amount, that's the amount that you're paying them back. In our case, it's $257.85. Now repayments, well, you've done no payments, it's 0. This is what we call an amortization table. You need to get familiar with each column. So here, notice, $1,000, how did they get $754.65? Technically, if you're only paying, if you've got $1,000 and you pay $257.85, we calculated that before. The amount should have been, and I'm just going to start from the beginning so you can see. So let's start from the beginning. If you owe $1,000 and you're going to pay back $257.85, this is how much should be left over. But that's not the case. You see, if you have a look at the table, that's not 242. The reason why is because there's interest. This is the interest table. How do they get that interest? Where $12.50 come from? That comes from our understanding that the rate was $1.25% per month. So they did $1.25% of $1,000 because that's what you owe at the moment. So what they did was they found 1.25% of 1,000. 1.25% just means 1.25 over 100 times 1,000. That's all they did. So on your calculator, I'm just going to type here just so you can see 1.25 divided by 100 times 1,000. That's where the $12.50 came from. Okay, so that's your $12.50 interest because they did 1.25% of your remaining balance. So how do they get $9.43? That comes from the same thing again. You're doing now 1.25% of the remaining balance, which is here. That's how much you're still owing them with the interest from last time. So now you're going to do, you can see here, if I follow that, I'm going to do 1.25 divided by 100 times, and what was the amount that I owe? $754.65. So $754.65. That's where the $9.43 comes from. See that? This table here is just replicating what you're doing there. So $9.43 was taking 1.25% of that. Where did $6.33 come from? 1.25% of the remaining. Where did $3.18 come from? Same thing. 1.25% of the remaining. Okay? So that's what they're doing right now. That's how you work out the interest paid. Amount paid is pretty straightforward. Every month you're paying 257, but notice that last one,